Welcome students. In this part of the video I am going to start new chapter, the p block elements, unit 11. So the p block elements are the elements in which the outermost electron enters in the p orbital. That's why they are named as p block elements, because they have the outermost orbital as a p orbital, or the electron which is present in the outermost shell, it must enters in the p orbital. Now first of all we have to know the elements of periodic table or the groups of periodic table which represents p block. So from group number 13 to group number 18, from group number 13 to group number 18, all the elements comes in p block. Group number 13 to group number 18, there are 6 groups. So all the 6 groups comes in p block. So whenever we have to check the elements present from group 13 to group 18, we have to know group 13, because in p block group 13, group 14, group 16, 15, group 16, group 17 and group 18 elements are there, and the first member of group 13 is boron. So this group is also known as boron family. 14th group, for 14th group the first member is carbon, so it is also known as carbon family. For group 15 the first member is nitrogen, it is also known as nitrogen family. For group 16 the first member is oxygen, it is known as oxygen family. Group 17 the first member is fluorine, it is also known as fluorine, or in short we can say halogen family. And for group 18 the first member is helium, and this group 18 is also known as inert gas group, because all the elements present in group 18, they all are inert gases. So these are the classification, or these are the group classification for p block elements. Now first of all we should know for p block elements, as we know that the last electron is entering in the p orbital. So as the last electron is entering in the p orbital, and we know that p orbital in a p subshell there are 3 orbital, and in a p subshell if there are 3 orbitals, and 3 orbital must have 6 electrons in it. Maximum 6 electron can be occupied in these 3 orbital, because one orbital has a tendency to occupy maximum of 2 electron. So obviously for 3 orbitals it can occupy maximum of 6 electron. So one by one the electrons will enter in a p orbital from group 13 to group 18, and that's why from group 13 to group 18 there are 6 group, because one by one electrons will fill from 13 for 13 group, 1 electron will fill in the p orbital. For 14 2 electrons will fill in the p orbital. For 15 3 electrons will be there in p orbital. For 14 for 16 4 electrons will be there in p orbital. For 17 5 electrons will be there in p orbital, and last for 18 group 6 electron will be there in p orbital. So that's why p orbital have 6 group by the because of the filling of electrons one by one from group 13 to group 18, and maximum of 6 electron can be occupied in p orbital, because p subshell has only 3 orbitals, and 3 orbital can occupy only maximum of 6 electrons in it. Now come to the electronic configuration of these p block elements. Electronic configuration, or the valency electronic configuration, or you can say the general electronic configuration of p block elements, it is ns2 np 1 to 6 electron. This 1 to 6 means the electrons present on it. This 1 to 6 means the electrons present in the p orbital. So in 13 group the electronic configuration must be ns2np1, because that is the first group of the p block element. So one electron can be filled in the p orbital, so it must be ns2np1 for the 13th group. For 14 it is ns2np2. Similarly, when you come to group 18 or the last group of the p block element, the electronic configuration will be ns2np6. so that's why the general electronic configuration for p block element is ns2 np1 to 6. It means electrons can be filled from 1 to 6 in a p orbital. So the general electronic configuration for p block element is ns2np6, but except for helium. In case of helium, as helium comes in group 18, but for in case of helium the electronic configuration is not ns2 np1 to 6, it is only ns2. Why? Because helium has atomic number 2. We know that helium has atomic number 2 and the electronic configuration of helium is ns2 only, but it comes in p block element because of its inert nature. It has been placed in the group of p block element where the inert gases are present. क्योंकि हीलियम का जो नेचर है वो इनर्ट है, वो किसी अदर सब्सटेंस के साथ रिएक्ट नहीं करते, वो इनर्ट गैस की तरह बिहेव करता है, इसीलिए उसे पीरियोडिक टेबल में जो इनर्ट गैसेस हैं उसकी कैटेगरी में उसे पुट कर दिया गया है. अदरवाइज हीलियम एक ऐसा एलिमेंट है वो p ब्लॉक में प्रेजेंट है, बट उसका लास्ट इलेक्ट्रॉन p ऑर्बिटल या p सबशेल में एंटर नहीं कर रहा है, p ऑर्बिटल में एंटर नहीं कर रहा है, बट फिर भी हम उसे p ब्लॉक का एक एलिमेंट हम उसे एज्यूम करते हैं ओनली बिकॉज उसका इनर्ट नेचर है, वो इनर्ट गैस की टेंडेंसी को शो करता है. सो दिस इज द रीजन. नाउ कम to the next part, the as we have seen, the general electronic configuration is ns2 np1 to 6. Now the elements of p block element, as we have already discussed, the maximum of 6 electron can be occupied in the p block element. That's why it is from 1 to 6. It has been shown here. Now come to the oxidation states of p block element. These are some general characteristics which we are discussing here. As we have discussed about the electronic configuration, so with the help of electronic configuration we can solve many of the physical properties of these group elements, like its atomic size, its ionization enthalpies, and its ionic size, and so many physical properties we can discuss with the help of this electronic configuration. Now as we have to move forward for the next characteristic of these p block elements, so the next characteristic is the oxidation state. So the p block elements shows the oxidation state, and that oxidation state is known as group oxidation state of p block element. That type of oxidation state is known as group oxidation state, because in p block element the valency electrons present, the outermost electron are the valency electrons. So the outermost electron or the valency electrons shows the oxidation states, or they are responsible for the oxidation state of the p block element. So in p block element it is group oxidation state because of the valency electron of s orbital, because ns is also there, and because of the p orbital also. So the valency electrons of s orbital and the valency electrons of p orbital, they both are responsible for the oxidation states of p block elements. And one more thing which we have to know, p block elements can have a tendency to show two type of oxidation state basically. As one type of oxidation state, as I have told you, one type of oxidation state is about the group oxidation state or the combined oxidation state, we can say, in which the valency electron of s block element and the valency electron of p block element can combinedly be counted. And one more thing, some of the heavier elements of p block, they have a tendency to show less than 2 unit less than the group oxidation state, some of the elements, और these elements are the heavier elements basically. So कुछ elements ऐसे भी हैं जो group oxidation state के अलावा अपनी stable position में, वो जब group oxidation state से 2 unit को हम और less कर दें तो उस oxidation state पे वो stable रहते हैं. तो it means p block element दो तरीके के oxidation state show कर सकते हैं. एक तो अपनी group oxidation state को show कर रहे हैं and second वो ऑक्सीडेशन स्टेट शो कर रहे हैं जो ग्रुप ऑक्सीडेशन स्टेट से 2 यूनिट कम हो. तो दो तरीके की ऑक्सीडेशन स्टेट उनके पास है. ग्रुप ऑक्सीडेशन स्टेट मोस्टली लाइटर एलिमेंट शो करते हैं. लाइटर एलिमेंट मीन्स जो उनके ग्रुप मेंबर्स में लाई कर रहे होंगे अपर पोजीशन में, दे विल बी द लाइटर. और जो डाउनवर्ड पोजीशन में ग्रुप्स में प्रेजेंट है वो हैवियर एलिमेंट्स हैं. तो मोस्टली जितने भी लाइटर एलिमेंट्स हैं वो तो ग्रुप ऑक्सीडेशन स्टेट शो करते हैं, बट जो हैवियर एलिमेंट्स हैं उनकी टेंडेंसी होती है कि वो लेस 2 यूनिट्स लेस देन द ग्रुप ऑक्सीडेशन स्टेट शो कर सकते हैं. और ये जो उनकी टेंडेंसी है कि वो ऑक्सीडेशन स्टेट से 2 यूनिट less oxidation state show कर रहे हैं, this tendency is known as inert pair effect, and we will discuss this effect in particular groups, because in this chapter we have to learn 2 groups of the p block elements, group 13 and group 14. So we will discuss this inert pair effect when we will discuss the groups group 13 and group 14. Now let's summarize the electronic configuration and the oxidation states of groups of p block elements in this table. So as I have already told you, the p block elements have the group starts from group 13 to group 18. There are 6 group in total, and the general electronic configuration for the p block element it is ns2np1 to 6. So for group 13 elements the electronic configuration must be ns2np1. It will the p orbital will start from one electron and it will end with 6th electron. So for group 13 element the general electronic configuration will be ns2np1, and for group 13 element the first member is boron, as we have already checked it. And the group oxidation state of group 13 element, group oxidation state means the combined form of the oxidation state or the combined oxidation state of, or the valency oxidation state of group 13. So combined form or combined electrons present in s orbital as well as of the p orbital. So electrons present in s is 2 and electron present in p is 1. So total number of electrons are 3. So the group oxidation state of group 13 element, it will be +3, +3. And as I already told you, the heavier element shows 2 unit less than the group oxidation state. They have a tendency due to inert pair effect, and due to this the 13 group element has that oxidation state will be +1 because it is 2 unit less than the group oxidation state. Group oxidation state is 3. 2 unit less means group other oxidation state must be +1. Now come to group 14. Similarly for group 14 the general electronic configuration will be ns2np2. Next electron will enter. The first member is carbon. The group oxidation state will be the combined form, 2 electron of S, 2 electron of P, so it will be +4 group oxidation state. And the other oxidation state, it shows two other oxidation state, +2 and -4. Similarly, when you come to group 18, the general electronic configuration will be ns2np6, but in case of helium, except helium has only one s2 configuration, as I told earlier. And the first member of group 18 is helium. The group oxidation state must be 8, but the other oxidation states can be +6, +4 and +2. In detail, we will discuss these oxidation states and group oxidation states in particular groups when we will discuss the groups of p block elements individually. So now come this is the interesting point of for p block elements, that p block elements contains non-metal as well as metalloids in it. in P block elements there are metals as well as metalloids, and as we know, according to the general trend, the metallic character decreases left to right and metallic character increases down the group. And the opposite will be for non-metallic compounds. Non-metallic character will increases left to right in a period and non-metallic character decreases down the group. So similarly, the non-metallic character decreases down the group for p block elements, for the groups of the p block element, and due to the decrease in the non-metallic character down the group, the last member or the heaviest member of the p block element will be most metallic in nature, and that compound will be most metallic in nature. And whenever a non-metal, highly reactive non-metal combines with a metal which is highly reactive, they form ionic bond with each other also. Now let's see the non-metals, because non-metals, whenever we have to check the properties of non-metal, so non-metal has very high ionization and energy or enthalpies as well as high electronegativities. So due to high ionization enthalpies and high electronegativities, then as compared to metals, non-metal have very high ionization enthalpy and high electronegativities. That's why non-metals can act as anions and metals can act as cations. Due to very high ionization energy, non-metals can act as anions, but metals can act as cations at that time, because the ionization energy of metals are lower than the non-metals. So electron can easily be removed from metal and they can behave as cation. Positive charge will acquire on metals, but non-metal have very high ionization energy, so they behave as anions. This is the difference also. Now this is only about the introduction part of p block element. Now in detail we will discuss p block group 13 and group 14 of p block elements in our further videos. So thank you.